So let's start with the goals of this course. And some of you may have seen these course objectives already. They are published on the website. And there are 4 main objectives for this course. So these are the things that you should know by the end of the course. And the first one is to be able to understand and use cryptographic algorithms. There's a wide range of different types of cryptographic algorithms. There is symmetric encryption, asymmetric encryption, cryptographic hash functions, and so on. The goal is that you are able to understand how these work and that you are able to use them. A second topic, and maybe even more important, is to be able to understand and identify security flaws in these cryptographic algorithms. As we will see throughout this course, many of these algorithms that have been proposed in the past actually have security flaws. And usually it's just a matter of time before a flaw is discovered and a new algorithm needs to be developed to replace the old one that's no longer secure. And I think it's very important that you will be able to understand whether one of these algorithms is flawed or not, and to be able to identify security flaws yourself. The third topic is to design and develop secure distributed software. So based on the algorithms, which is the first part of the course and which is more theoretical part, we will learn how to use them in software applications that you will develop yourself. There are also several lab sessions where you will be able to apply the theoretical knowledge in real software applications. And finally, the fourth topic is to be able to configure and deploy secure computer network protocols and policies. As you will see, security is very important in the communication between different users across a network, for example, when exchanging data over the internet. And applying these cryptographic algorithms to secure network communications is therefore very important when developing, for example, distributed applications. And why is it so important that you learn about security? Well, security is all around us. Every day when you're using the computer, you get in touch with these cryptographic algorithms. For example, when using the internet, you will probably surf the web using HTTPS. HTTPS is a secure version of HTTP, and it uses the Transport Layer Security Protocol, or TLS. Maybe you've used SSH, or Secure Shell, to log into a remote web server in a secure manner. You've probably used VPN, which can rely on, for example, the Internet Protocol Security Suite, or IPsec. And when using Wi-Fi, in many cases, you need to use a password, which is used for WPA2 or WPA security to secure your traffic. Also, a lot of other wireless protocols like Bluetooth, GSM, LTE use security and encryption to secure your data. Also, when storing data, cryptographic algorithms are used, for example, when storing data on a disk, using the encrypted file system standard, secure password storage in a database, protection of content, for example, on DVDs or Blu-rays, and so on. So security is all around us and is very important. And I also have a graph here to illustrate how important it really is. So this graph shows the number of large data breaches that affected people in the US, so customers in the US, throughout the years from 2005 until 2019. And as you see, there's a clear increasing trend. So throughout the years, on average, more and more breaches happen. There can be multiple reasons for this. It could be due to the fact that software becomes less and less secure, or due to the fact that hackers become more versatile and try to find more of these breaches. But no matter what is the reason, this clearly shows that it is more and more important to embed security into the applications that store or transmit or manage our data. And these are not the amount of data instances that have been leaked to hackers. This is actually the number of breaches, so the number of websites or companies that have been breached. And each of these corresponds to hundreds of millions or even billions of user records. For example, one of these 1,473 breaches in 2019 was a large data set of Dropbox and LinkedIn user accounts that had been leaked, consisting of more than 2.2 billion user records. So in total, all of these breaches together account for tens or even hundreds of billions of user records that are made available on the dark web by hackers. Some other large breaches that occurred in 2019 are Google Cloud and Evite, also accounting for more than 1 billion records each. So even big companies like Google that you would expect to be very strong in security get attacked by hackers and get their data stolen. And the main people suffering from this are not these companies, but actually the users whose data, such as personal information, password, credit card information, gets stolen in these data leaks. So let me give you one example of one of these breaches, and it actually occurred quite a long time ago, 8 years ago, but it's a very famous one. It was the LinkedIn hack of 2012. The thing is, however, LinkedIn did not admit to this until 2016. And this is something that occurs very often, that a website gets hacked and the company behind the website tries to hide this. Instead of notifying the users, they try to hide it for several years until the data becomes publicly available somewhere and everyone finds out that the website was actually hacked. This is very problematic because the password of the user gets stolen and the users only find out about this several years later. And what happens is they use this password also for other websites, so the hackers not only get access to their LinkedIn account, but also to all other accounts where they use the same password. And what happened is that over 100 million user accounts got hacked, and this information included usernames, passwords, email addresses, and so on. All these records, these stolen records, were then being sold online on the black market, for example, on the dark web. So anyone could just buy the email addresses and passwords, LinkedIn passwords of all of these 717 million users. And the worst thing was, so these passwords were not stored in plain text in the database, which is good, but they were hashed using insecure algorithms. So normally when you store passwords in a database, you use a cryptographic hashing function to secure them. But the hashing function that was used in this case was SHA-1. And SHA-1 has been considered insecure since 2005. So LinkedIn was still using this over 7 years later. And it was known that SHA-1 was easy to decrypt. Moreover, they didn't use salts. We will learn in a couple of weeks what is a salt exactly. But what it comes down to is if you hash the same password twice using the same hashing algorithm, it will result in the same hash value. So that means if the hackers can decrypt this hash once, they also know that all the other users with the same hash password will have the same plain text password. If you use a salt, this is no longer the case. So that makes it much more difficult to decrypt all these hashed passwords. But LinkedIn was not using salts, which has been the standard for many, many years. So on one hand, the user information got stolen. On the other hand, LinkedIn did not use state-of-the-art security mechanisms to protect the user data. And as a consequence, now all these passwords are actually out in the open. You can find online this information, and it's very easy for anyone to find it actually. And that brings us to a question that I would like to ask all of you. So the question I would like to ask you is, which was the most common password found in the 2012 LinkedIn hacked user database? And it may surprise you that it's actually one of these very weak passwords. Okay, so while the final answers come in, it's clear that these passwords are not very secure, because if you use a very common password like these simple phrases like the name of the website or 123456 or QWERTY or just the word password, it can very easily be hacked using a so-called dictionary attack. We will learn more about this in later lectures, but what it comes down to is that hackers already pre-hash all these very common words. So they just take a dictionary of common words and common passwords. They already make a hash value out of it in advance. And then when they get their hands on the database, they can just compare those hashes to the hashes in their dictionary database and quickly find a password. This becomes more difficult by either using a password that's not very common, that doesn't occur in these dictionaries, or by salting the hashes when adding them to the database. But let's take a look at which was the correct answer. And the correct answer was 1, 2, 3, 4, 5, 6. Definitely not a very good password, but it was used by many people. And actually here you see the occurrence percentage of these common passwords, and actually of all the top 10 common passwords. And 1, 2, 3, 4, 5, 6 was used by over 12% of all people in the database. So 12% of all the hacked accounts were using 1, 2, 3, 4, 5, 6. That's incredible, I believe, in my opinion, and it's makes the job of the hackers much easier. If we look at the total top 10, 24% of the users, so 1 out of 4 users, was using a password from this top 10. So this is actually a very bad idea, and it shows that people were not or are not very concerned with securing their accounts. So this was, of course, in 2012. I hope now people have learned from these past mistakes and use more secure passwords.